So in this video we're going to discuss fatigue in welded joints, and this is just a real brief discussion, and to make a couple points. Number one, the fatigue life of welded joints is lower than a equivalent solid section. So if the section was contiguous, it would have a higher fatigue life than a welded joint. So to highlight that, if we had a joint like this that was welded, it would have a lower life than if you had a component like this that was machined out or fabricated from an alternative process. Number two, the endurance limit. Okay, this is the infinite life endurance limit that you might remember from your SN curve for steels. Looks something like this. So we say there's an endurance limit here such that, or maybe SE, such that if you stay below this load line, you'll have infinite life. Well, the endurance limit is lower for welded joints, and if you have an application where you have a weld and fatigue, you need to do some more analysis. Okay, so my job here is to make sure that you understand that they're not the same and that you need to go and build confidence in your design if you have a welded joint and fatigue. Number three, stress concentration factors are applied to welded joints. Okay, and you can look these up in your book, but they vary, and you can look them up in the machinery's handbook and other places, but they vary for stress concentration for fatigue is, let me rewrite it like this, it's between 1.2 and 2. Okay, so not as high as some other stress concentration geometries, but the main point here is if you have a welded joint, you can apply a stress concentration of 2 to cover most welded joint types, and you can look those up. If you have a messy weld and you don't have a good process, or you don't do a good job welding, then you can get voids and inclusions in your weld. They can also show up when you're careful, but you can have voids and inclusions in the welds, and these lead to local stress risers or stress concentrations, and that's why we have to maybe use a reliability factor, okay, in our fatigue design to kind of account for some of those things. The last thing is maybe counterintuitive, but grinding the welds flat can actually increase the fatigue life. Okay, so for example, if you have a fillet weld like here, and that filled weld is like nasty and has some problems in the surface, and then you apply some loads to the structure, well, that crack in the weld, it might be easier for it to grow and cause problems if you have a nasty surface here. So if you have a nasty surface from a weld, you can actually increase the fatigue life by grinding that surface down to the nominal surface of the part. So this is one of the cases where removing material can actually improve the life. Okay. So those are the points that I wanted to make about fatigue in welded joints.